I'm not going to revise that. Revise a little bit. So we have 4 rules for congruent, and we have 4 ways to prove they are similars for similar triangle and congruent triangles, and they are all in pairs. Okay, they are pretty much using the similar informations. And if we have 2 triangle ABC and we have EDF, and I want to prove those 2 are similar triangles. And first of all, let's see, 1 is the smaller one and 2 is the smaller one, so 1:2 ratio. B, C, and EF are the longer ones, so 3:6 is 1:2 ratio, so you have the same ratios and you have same angles. So what you would do is, write AB over DE equals to 1:2, BC over EF equals to 3:6, and that equals to 1:2. So the ratio AB over DE must be equals to BC over EF. Okay, same ratios. And also you know another information is angle ABC equals the angle DEF, and that equals to 120 degrees. It's not really helpful for 120 degrees. It can be any number. But like you have 2 angles equals to each other. So the triangle ABC is similar to the triangle. Okay, let's see the corresponding point. 1 and 2 are the corresponding side. Then the angle opposite to that will be 2 corresponding angles. And you have B and E are similar, are the same angles, and you have A and D must be a pair. So you write A, B, C. So A will corresponding to D, B will corresponding to E, C will be corresponding to F. So A, B, C is similar to the triangle DEF. Okay, that's how you find the corresponding pairs. 3:6. Okay, for the next one, I can see right angle triangle. Okay, I can see right angle triangle. And the information we know is 1 hypotenuse and 1 side length. 1 hypotenuse and 1 side length. So it will very likely to be the RHS case. So I will say triangle ABC and triangle DEF are right angle triangle, so RT triangle, so it's right angle triangle. Okay, so you have AC over DF equals to 5/10, and that gives you a half. And then the 2 side lengths, BC over DE equals to 4/8, and that is 1/2 as well. So you will say AC over DF is the same as BC over DE. So the conclusion will be triangle ABC is similar to the triangle. Okay, A is here, so it's corresponding to opposite to 4. So that will be opposite to 8. Okay, 4 and 8 are the corresponding pairs. Then you will have those 2 pairs. And then C and D will be a pair. Okay, C and D will be a pair. So A, B, C. So A is corresponding to F. So you will start from F. B is the right angle, so E will be the right angle. C will be the square angle, and the green angle will be D here. So it's actually not DEF, it's FED. Okay, ABC is similar to FED. The order does matter. Okay, when you have your test, you need to write corresponding points in the same position. Okay, corresponding points in the same position. By RHS. Okay, let's write by what? This one is by SAS. Example 2. Find the value of the polynomials. Okay, find the value of the polynomials. So Again, we cannot directly use those two triangles as similar triangles. You can see, okay, they are similar triangles, but I cannot use it directly. I need to prove it is similar triangles and then use the properties. So, like this shape is a very typical shape. So it's a big right angle triangle, and you have a vertical line, and you have a small right angle triangle. So let's give the points some names: A, B, C, D, E. Okay, A, B, C, D, E. Let's say the angle ABC will equals to the angle DEC. Okay, this angle will equals to that angle. Okay, the angle ACB. Okay, can you see all these 3 points that uses the big triangles points ACD. Okay, do not use CED in the front because all the left one I want to start with the big triangle. Okay, I want to start to write things in the big triangle. So ECB will equals to the angle DCE. Okay, will be the 3 points here. DCE. Okay, equals to that. So that is right angle. That's given, and this one is the common one. Okay, that's the common. So because of that, therefore the angle BAC will equals to the angle EBC. Okay, this angle will be the same as this angle. Because two pairs already equals to each other, then the third pair must be equal as well. So the triangle ABC will be similar to the triangle. Okay, A is corresponding to D, B is corresponding to E, and C is corresponding to C. So it's similar to the triangle DEC. Yep. You don't need to write that. Like it's like we all know that. Like two pairs equal, then the third pair must be equal. So that is by AAA. Even though we have the length 1.2, 3.6, but I only have one pair of the length, so it doesn't really help. It doesn't really help. So it's all by angles. Okay, we know that all by angles. So therefore, I can start to write the ratios. So I will start with the big one as well. So AB will over the DE equals to the length opposite to A, which is BC. Opposite to D will be EC. So those two pairs must be equal. I'm not going to write the third pair because there's no numbers and no variables and no polynomials. Why I need to worry about the third pair? So I only worry about two pairs, and those two pairs must have the same ratio. Therefore, I will have 3.6 over 1.2 equals to BC is 6.6 over X. So that will give you 3 equals to 6.6 over X. 3X equals to 6.6 and X equals to 2.2. X equals to 2.2. So that's the first one. And the second one is the one I really like, because for this question, students don't know which two should be the pair. Okay, because a lot of mistakes occur in this question, that's why I like this one. It can really test your understandings on corresponding pairs. So what kind of length can be corresponding length is the one opposite to the same size of the angle. Okay, in this triangle, this angle equals to that angle, then the two opposite sides must be corresponding lengths. So let's have a look at this one. You can see about 4 single triangles here. Okay, we can have this one, we can have this one, we can have this one, and we can have this one. So which two triangles you will use? And the first thing we'll start to think about, it must be a similar triangle question, and I need to use 2 triangles, and which two we should use? We should really use the ones contain all the numbers and contain all the polynomials. Again, we need to include all of those informations. if we use this one and this one, 8 and 24 just missing from your like two triangles, so I cannot use that one. So I can use this one and this one. Okay, I will use those two triangles because it can have all the numbers involved. Okay, all the number involved. So what this sign means? This one means those two lines are parallel to each other. Okay, when you see that on the graph, the red part, that means parallel to each other. They are parallel lines. So let's give a point. Let's point a point O here. Okay, let's say that's O. Let's say we have A, B, C, D. Labeling that way. Okay, we have A, B, C, D here. That's the point O. So you start with, because AB is parallel to DC. AB is parallel to DC. So the angle ABO equals to the angle CDO. So what that means, which one is that? We have ABO, which is this one, and CDO, which is this one. Okay, because of alternate, let's see the two green angles. Okay, and we can find another pair of alternate angles. So another pair will be angle BAO equals to angle DCO. So which one is that? BAO, which is this one, and then we have DCO, which is this one. Okay, this black pair. And also, this is alternate. Alternate angles in parallel lines must be the same. Then also the angle AOB equals to the angle COD. Okay, which is vertical opposite, or you can say two pairs already equal, then the third pair must be equal, like by two kinds of reasons. Okay, the vertical opposite can be equal, or I can say it's the third pair. So the conclusion is AOB must be similar to the angle COD. AOB, okay, A is the black angle, so the black one is C, triangle C, O is still O, B is the green one, which is D. So AOB is similar to COD by AAA. Okay, I must say, like in the real application questions, like in most of the application questions, 85% of the time you will use AAA to prove two triangles are similar triangles. Because it's very hard for us to get information for length. It's always to see angle will be the easier way to prove that. And in application questions, like I think like about 90% of the time you will use AA to prove that. Unless like if giving questions like that on purpose ask you to use all of those rules, and you can use SAS, RHS. But most of the time you will use AAA. See, the first one is AA, the second one is AA as well. You always think about angles because angle is the easiest way to think about similar triangles. Okay, so we have those two triangles that are similar triangles, and you want to connect all of those informations together. And I will write ratios for 3 pair. Why I write ratios for 3 pair? Because I have like 6 numbers in total. So I will write, the first one is the longest one is AB over, okay, opposite to this one must be BCD. Okay, AB must be opposite to CD. Okay, next one, I will start from my OA. Okay, tell me what is the corresponding pair? OC or OD? OC, okay? You can see it's OC now because I have like, wait, which one? I have write OA and OC, yeah, the green one. Okay, this green one opposite to OA, then OC is opposite to the green one, so must be OC here, not OD. And then OB will be opposite to, OB is here, opposite to the black one, Then the bottom one, black one, is here opposite to OD. So OB and OD is a pair. There are so many students making mistakes because they write different, like swap the bottom. OA divide OD equals OB divided by OC. Okay, a lot of them doing that last year. So make sure you label out all the like angles, and then you put that into the ratio form. So let's put all the information in. AB over CD is 24 over 8. OA is 12. OC is A. OB is B, and OD is 5. So that ratio equals to what? By calculate this, you can know the ratio is 3. Okay, the ratio is 3. The longer one divided by the smaller one should give you 3. So 12 divided by A equals to 3. A must be 4. And B divided 5 equals to 3. B must be 15. So A is 4 and B is 15. A is 4, B is 15. Like what happened is like it's not you can directly start with this step. Okay, if you can do it correctly, you can do that, and if you get all the correct answers, it will be marked right. But the problem is if you make any mistakes there, say you copy a number wrong, or you copy something wrong, or you calculate that wrong, you may not get in the method mark at all because I can't see the method. It's not in this ratio form. So it's better to write out the ratio and then substitute numbers in. But like it's not like really easy to make mistakes in this question, so it's okay to start with the star. Okay, so that's the 2 questions here, and let's look at example 3. For example 3, a core has radius 2 centimeters and height of 4 centimeters. The top of the core is cut horizontally through the point D. Okay, from a point I cut that in that way. If AD equals to 1, so I cut a height of 1. Okay, from the top, the vertex, I draw like 1. I find a 1 and I cut it horizontally. Find the radius of DE. I want to know what's the radius at the bottom. Okay, what's the radius for the base? What the thing I have cut? It's a 3-dimension shape, so I will put the question back to 2 dimension. Okay, I'll put the question back to 2 dimension. So for 3-dimension thing, we always do is to put it back in 2 dimension. So let's have a look at this triangle. That's a triangle. Okay, it's the slant height and the actual height and the radius. They can form a right angle triangle if you can imagine that. Okay, the vertical one have a radius at the bottom and with the slant height, that can give me a right angle triangle. And similarly, when we cut that, this part can give me a right angle triangle as well, because I cut it horizontally. The radius still like make a straight line, the perpendicular line with the height. So that's a 90 degree as well. Can see this shape come again. I think it's the 3rd time we deal with this type of question already. So we need to prove those 2 triangles are similar triangles, and then we can write ratios. So what we know is AD. So we know AD is 1. And I also know AB is 4. Okay, we also know AB is 4. So what I will write is the angle ADE equals to the angle ABC equals to 90 degrees. That's given. And the angle DAE equals to the angle BAC. That is common. Because of that, so the 3rd pair must be the same. So therefore AED must equals to ACB. Therefore the triangle ADE is similar to the triangle ABC by AAA. Okay, still proved by AAA here. So therefore I'll write ratios. Okay, I start to write the ratios. So AD is the height over the whole height of AB must be equals to DE, which is the radius of the small core over BC. AD is 1, AB is 4, and DE is unknown, BC will be 2. So DE is that times 2, and DE equals to a half. DE equals to a half. Okay, because we still have a lot of space here, I want to add one more part for this question. So part B is asking the part has been cut, has a volume of 2 centimeters. So what's that? Let me calculate that. Half third times h. So is 12, 1 12, 3. Say a volume of about let's say it's about a quarter centimeter cube. Okay, it's not an accurate value, but let's say it's about a quarter centimeter cube. What is the volume that has been left? So what has been left? I want the bottom part. Okay, so the part that has been cut is about a quarter. Do not calculate that by using the formulas for measurement. Use ratios. Okay, use ratio to calculate. So use ratio to calculate. We have talked about that last week. Yep. So the small part that has been cut is a quarter. Okay, it's a quarter. And you should know that the small corn which has been cut will be similar to the big one. Okay, the small one will be similar to the big one. Why? Because the height and radius are in the same ratio. Then the two corn must be similar corns. Okay, similar shapes. So small corn and big corn are similar. So the length scalar factor will equals to 1/4. Okay, the small height over the huge big height. Okay, 1/4. The one I have cut is 1 and the big one is 4. So the length scale factor is 1/4. Then the volume scalar factor equals to so small volume of the small one, so say Vs and Vl. Okay, the volume of the small one over the volume of the large one equals to a quarter cube. Okay, a quarter cubed, because the volume scale length will be the same as scalar length times cubit, not times, cubit. So what you have, the volume of the small one is a quarter over the volume of the large one equals to 1 times 4 times 4 is 16, 16 times 4 is 64. Okay, so it's that. And you can do cross multiplication. So the volume of the large one equals to a quarter times 64, and volume of the large one will be 16 centimeter cube. Okay, the huge corn will be 16 centimeter cube. Okay, the volume, the small volume on the big volume will be 1/4 cubic. Okay, you cube that. And I have worked out the big one, but the small one has been cut. Yes? Like then you will change V large over the V small. You just change it because the small one's always on the top or the small one's always under the bottom. You can do whatever you like, but like you need to make sure all that will be all on the top or all under the bottom when you write it. So it's 16 centimeter cube. And then what has been, so V remaining will be V large subtract the V small, which will be 16 subtract a quarter. Okay, 16 subtract a quarter. So times of 4, 64, 63 over 4 centimeter cube. 63 over 4 centimeter cube. Okay, that is what has been left.